Well, welcome and thanks for coming. My name is Laurent. I'd like to talk to you about task output caching in Gradle. So the title of this talk, I think, is still distributed caching on the schedule. So please don't be disappointed. We're going to talk about that as well. So this is a pretty new project. It just born a few weeks ago, but we've been anticipating it for a long, long time. And we're still figuring out what it's capable of, or what we are going to be capable of with what we are doing. So I changed the title because it's about more than just distributed caching, as you will soon see. So I'd like to talk to you about this upcoming feature, which I'm not allowed to say when we are going to release because we don't yet know. But what I want to do today is to put this new feature in perspective related to all the other caching strategies that Gradle employs today around task execution. And I also would like to talk a little bit about what we need to do to make this as awesome as possible. And when I say we, I mean us at Gradle and you as plugin developers, as build authors, as task creators. We all can do some things to make sure that this is really going to be awesome. So yeah, let's just jump in. So when we're talking about caching here, I think I'm using it a little bit broader way, just meaning that how can we avoid doing work that has been already done before in any way. And we are focusing around tasks. So Gradle does a lot of caching during configuring a project. It does a lot of caching with downloading dependencies and all kinds of stuff. We're not talking about that. We're talking about just when Gradle has already decided that we need to get the results of this task. We just want to try to avoid actually executing that task because it's probably pretty slow. So what's a task in this sense? Well, it's an operation that takes some inputs and produces some outputs. And there's a very important property of a task, which is that it's reproducible. So given the same inputs, the same task will always produce the same outputs, right? Not all of the tasks we have today are like that, but well, let's talk about that a little later. Let's talk about now what these inputs and outputs are. So inputs come in many forms. One of the inputs for a Java compile task, for example, is the source compatibility. It's a property that you need to set, or it's set automatically. That tells the Java compile task what Java version it should treat the sources as. And of course, you have source files and a source class path. So basically, you have input files and input directories and whatever, but in nature, files as inputs to a task. There's of course outputs. Outputs for Gradle tasks are always files, directories, stuff on the disk, right? So, and there's another really important bit that we treat as inputs is the task itself, the type of the task itself, right? If this is a Java compile task, that's a different story to a Groovy compile task, right? If I change it from one to the other, that's a different. That can influence the output, and in general, we call the inputs to a task are the things that can potentially influence its outputs. If it's something that does not influence the outputs, it's not an input. For example, the verbose option to Java compile is not an input in this sense because it will not influence the file output of the task. It influences only the console output. Okay, so much for definitions. How do you tell Gradle about your task? How do you specify which properties hold what kind of data? Can you read this? Is it okay? Okay, cool. Can't read it from here, but that's fine. Okay, so yeah, so we have these nice annotations. That's one great way to tell Gradle that hey, encoding here is an input property, and we have input files and an output file. So sort of already tells the story of what this task is going to do. So what can we do with this information? And this is the first caching strategy sort of that we are currently using in Gradle. So given this information about what the inputs and the outputs of the task are, we can look at the task before we are executing it. And if this task was executed before, we can just look at all the inputs, look at the source compatibility level, look at the input files, the Java source files, the source class path, and see if they are the same as during the last execution of this task, right? And we can do the same with the outputs, check if the files are there on the disk and if they are the same as they were after the last time we executed this task, right? And if the answer to both questions is a yes, then we know that we don't need to execute this task because we know that the inputs are the same, the task is the same, so the outputs must be the same and they are already there. So we can just print this little up-to-date label after the task and we are ready, right? This is a incremental builds is a core feature in Gradle for a long time, of course, and it works when all the content is the same as it was during the last time we executed this task as part of this build on this machine, right? There's the is the same part is important because we are. Can I do something with this too? It's probably a no. Okay. Sorry. No, it's here. Yeah. Okay, I'll just do this. Maybe I'll just do this. Okay. No, it's not. Anyway, so these are the same part. So Gradle is not interested in tracking modifications to these files, to input files, output files, whatever. You can delete them, you can modify them. The question is the content the same as it was during the last execution? The difference is important because, for example, if you make a modification to one of your source files and you change, for example, a comment, right? We still need to re-execute the compiled Java task because we don't know, we just know that the source files have been modified. But the resulting class files are going to be exactly the same as they were, and so the jar task, which uses these class files to, as inputs, is going to notice that its inputs have not changed, and we're not going to re-execute the jar task. So the cascade of modifications stops at that point, which is a cool thing. Okay, so that's incremental builds. We also have incremental tasks, which is a bit confusing, but that's a different story. So the previous strategy works really well in general. It usually saves you a lot of time because, well, most of your tasks are not influenced by every single change you make. Incremental tasks is a special feature aimed mostly towards languages like C++ and C, where you are doing compilation, for example, on a source file basis. For each source file, you execute a rather slow compiler. So incremental tasks is a feature where Gradle can tell your task which of the input files of the tasks are out of date and need to be reprocessed, right? So this works when some of the inputs remained the same since the last execution of this task in this build on this machine. And I want to show you just one more existing or sort of existing feature, which is Java compile avoidance. It's a really cool feature where basically Gradle understands that when you're depending on a library, that library is not just a jar file, but it's a combination of an API and an implementation. And if there's a change which only affects the implementation, we don't need to recompile your code when that happens. We need to re-execute any tests, of course, because tests do depend on implementations, but not the compilation part. And again, this feature works when the inputs are not the same, but they mean the same to the task as they did before. So all three of these strategies, incremental builds, incremental tasks, and Java compile avoidance, work with results from the last execution of this task as part of this build on this machine, right? And these strategies, they already save a lot of time for us when we are building software and working on in our local environments, etc. The question is, what we looked at is, are there other use cases where we could do more, we could do better, we could do something else that helps you avoid having to execute some tasks? Yeah, probably there are. So one of them is switching branches. I don't know if this is visible, but it's a very basic demo of building a small software on the master branch, and then obviously we need to run compile Java and jar because this is the first time we run this build. And then we check out a feature branch which has some differences to the master branch. So obviously when we build this branch, we get compilation redone again. And that's all fine. That's all to be expected, right? But when you check out master again, you go back to a state where we have been before, right? Why do we need to do the compilation again? Why do we need to do jarring that stuff up again? That should not need to happen, because we did this before. We know what the results are, right? So yeah, the question is, can we do something better here? And of course we can. So we can, of course, remember all the states, all the results from any previous state that we've seen, and reproduce them from a cache when we encounter them again. So so this is how the same story looks like with the task output cache. We again build the master with the cache turned on. First, nothing surprising there. The same things need to happen again. Okay, so yeah, this is the important bit where we rebuild master again when switching back from the branch. And of course, the nice thing is that compile Java and the jar task now are loaded from a cache. So basically nothing happened in this build. All the tasks were either already up to date or were loaded from the cache, and we saved exactly 0 seconds this time. But of course, the target audience for this thing is big projects with slow tasks and lots of them. So and of course, switching branches is just one of the use cases. You can also think about like trying something out, and this is really not working. Okay, do you have maybe a standalone mic? Okay, I'm really sorry. Maybe I'll just do it like this. Is it better? Okay. Yeah. So if you do something and then you decide, hey, this is not a good idea, you do git reset, you're back at where you started from, you rebuild again, you can use the cache again. And one other thing that would be really, that will really profit from this is when you're doing bisecting, which is like basically jumping back and forth in the Git history or whatever is your version control system, and trying to figure out where a certain bug was introduced or a certain performance regression was introduced. You're basically rebuilding all kinds of previous states, and this is going to make it so much faster. The infrastructure for this whole thing is not very complex either, right? We just basically try to execute a task, and the first time we see it, we ask the cache if we've seen these inputs before, and of course it's going to say that, hey, I haven't seen these inputs before, so we just execute a task, store its results in the cache, and the next time we execute, the cache is going to say that, hey, I've seen these inputs before for this task, so why don't we just reuse those results instead of executing the task, right? So not really a very mind-blowingly complex thing. So yeah, what took us so long? And of course, if we have this infrastructure, we can go further, right? Why would we be confined to the local current build, current Gradle project? When doing this, we can, of course, share results between other projects on the same machine. We can have a machine local cache, and well, Android pre-dexing is a prime example of where we can do much better. So yeah, it's a slow process. You need to do it for Java libraries to make them work on the Android VM, and there's no reason why this needs to be repeated for all your Android projects every single time if you are using the same library, and or to repeat it after you execute it clean, for example. So we can just, I don't know. Yeah. So yeah, we can share cached results between builds very effectively, and of course we don't have to stop there. We can share among the whole team. So if Joe has pre-dexed this library, I can reuse those results. Yeah. So that's the plan, and once we have this infrastructure in place, we can implement all kinds of different architectures. We can have a machine local cache that helps Android development. It helps switching branches. It helps bisecting. Or we can have a centralized architecture where CI pushes to this cache service that developers can pull from. Or we can, if you really trust everybody, and the trust is really broad here because you have to trust that people are not going to have network issues, or they're not going to push corrupted results into their local caches. You can have a fully distributed cache as well, pretty easily. So again, this is a new project. We are still figuring out what we can do with this and how exactly to proceed. But we are sure that there is going to be a machine local cache as part of the Gradle open source product. And we are also going to provide deep insight and analytics to the usage of any networked, any shared cache architecture with the Gradle cloud services offering. So that's going to be pretty cool, I think. And it's going to let you have a deep insight into how those caches are operating, what you can do to optimize them, and track down any problems you might have. So this is a good part. I think it's going to be a major step towards much higher performance builds. And as I said in the beginning, we need to also do some things to make sure that this works as well as possible. So we need to do some work. What am I talking about? So there are some problems, and these are not new problems. That's what is important to see here. That we had all these problems. I'm going to talk about with incremental builds as well. So when I'm talking about false negatives, when we are looking at a task and thinking that, hey, we need to re-execute this because the inputs and the outputs don't match up, whereas in reality we could just skip it because it would produce the same output anyway, right? That's a false negative. That's a missed opportunity to save time by not executing that task. So that these kind of problems affect performance, and that's when your developers are looking at the build and they're saying, why the hell does this task have to execute for 10 seconds every time I'm rebuilding, and they changed absolutely nothing related to it. And of course, it's really important to fix these things. And one of the really surefire ways to introduce these false negatives into your build is to have inputs which are not really inputs. We talked about the verbose flag. So If you include that as an input in your task, something which changes only the console output, right? Every time a user changes that, it's going to the task is going to be considered out of date and be re-executed needlessly, right? And of course, for caching, this would mean a cache miss, and we're going to upload the same results again under a different cache key and waste some time and disk space. So yeah, affects performance. Even more importantly, false positives when we wrongly identify cases to employ this strategy and not execute a task when in reality we should, are even more severe because they affect correctness. And the problem with that is of course that you can silently have results, builds which just produce some different output than they should, and you don't know about it. And again, one of the surefire ways to include to introduce these problems is to forget about telling Gradle that you have a property that is an input. And if you, for example, forget about encoding as an input, changing the encoding is not going to make your task out of date, and you think that you fixed that encoding problem, whereas you haven't really. So that's when you send out emails to Eastern European people with dashes in their names, not nice things. So yeah, don't forget to annotate your inputs, please, and especially if they are related to encoding. So yeah, this was a problem already, and if we are going to use caching, these are going to be much more severe, because of course it's not going to just affect the changes introduced since the last build on your local machine, but it can affect any future builds that are happening later on. And it doesn't just affect builds on your own computer, but also can affect other people's work, and they are going to have dashes for their names, and that's not cool. And of course, you can't use clean as a solution. We are pretty much used to, when it comes to any build system, when encountering a problem, we just run the build again with clean, right? I don't know, many of us, I guess, have done this, and some of our users sometimes learn this as a clean first policy, that if any problem arises, they don't trust the build, they just do a clean, waste a lot of time, end up with the same problem. Okay, now I go and check out what could cause this. This is not going to be so easy if we are sharing these results with each other, and so again, keeping the cached results really clean and correct is going to be much more important than with the up-to-date checks. But the good side of this is that whatever we do to fix these problems, we are going to fix them for incremental builds as well. So so that's cool. Less cleaning is required. I think that's the main goal here. Okay, so what are these problems that we can take a look at? So one of them is of course missing annotations or incorrect annotations, and one of the things we can do, and then actually 3.0 milestones already include this. So if you forget annotating your properties and you're using the Gradle plugin development plugin, then it's going to tell you that, hey, you're missing some annotation there, and you should make a decision whether this is an input, it's an output, and we have some new annotations to put on stuff which is related to the console output. So you can actually annotate everything properly. So that's one thing you can already start doing to make sure that we're not going to pollute each other's caches with incorrect results. Another thing, and this is on us as Gradle. So as we talked about this before, the task implementation is it should be part of the task's inputs, right? So if I change a Java compile task to be a Groovy compile task, it will result in somewhat different outputs with the same inputs. And we do check that in today's Gradle. So if you do this, it will be making the task out of date. But if you have a custom task, for example, which is defined in your build script, and you change the code there, the current Gradle is not going to recognize this change as a reason to re-execute the task, nor will it re-execute the task if you upgrade the plugin that declares this task. And well, this has been fixed in 3.0, so that's a good thing. And again, this helps incremental builds as well. Tool chains is another thing. So we currently don't take into account, for example, in Java compilation, which Java version you're using. So if you replace your, unless you explicitly specify the Java version, the Java compiler to use. So the default tool chain being used is not recognized. So if you upgrade your local Java, we are going to consider your tasks still up to date, even though that they should be recompiled with this new Java version. Same story for native compilation. This is something, again, we need to do on the Gradle side. Another new thing about a shared cache is how we treat file paths, right? If there are two team members who are sharing the same cache, and they have some task which is executing with this file as inputs, right? The absolute path of these files will not ever match up for all kinds of reasons. So we need to be, so the question again is what part of the input is that, what is influencing the output, right? Is the file name important? Is some relative part of it important? Is the full path important? So for example, for a Java compilation, a Java source file matters only the file name matters, right? The Java compiler does not care about the rest of the path. If you change the file name, that's a difference. But if you just put it somewhere else, it doesn't care about that. If you have a class path, we don't even care about the file names on that class path, right? It's just the contents of the files. On the other hand, if you look at the order of the files, for Java compilation, for the sources, we don't care about which order you give us the sources, but we do care about the class path order, right? Because if you change that, that can change things big time. So we need this information. We didn't need this before because, well, we didn't need the file path information before because everything was just considered locally, so the absolute path was good for everything. We did not have to compare projects in different directories or projects on different computers, but now we need this information, and we need to, well, this is not final API, but this is one way we could do this. So adding some new annotations to properties and specifying how to treat those files in those properties. Okay, and there's one more thing I want to pick out. There's lots of other things. Maybe we're going to write blog posts about this or just put it in the release notes or documentation. But this is another very important thing. So Gradle has been very lenient about different tasks writing to the same output directory, for example, or in any other way having overlapping outputs, right? And this is not just a problem for caching, it's a problem for parallel execution, it's a problem for cleaning up outputs of the task, because we don't know, for example, if two tasks are writing to the same directory, we don't know which files belong to which task. We are actually doing some clever things, looking at which files have changed after the task execution, but it's not a surefire way to do it, because there's a number of problems with file systems having very coarse-grained timestamps and all kinds of other problems that can arise from this. So basically what we are going to do is to switch off caching for a task if its outputs are overlapping with another task. So what you can do today again is to look at your builds and refactor them so that every task has exclusive access to its output directories, output files, and there's no overlapping between these outputs. So yeah, there's all sorts of things. 1 second and I finish, and we can make questions if it's yeah. So yeah, that's those are the things that we can both do. We also have some tasks that we ship with Gradle, so we are doing. Sorry. Shut up. What? Phone. Oh. It's okay. I can put it on airplane mode. Is okay. Okay. I'll finish in like 2 minutes. So okay. Yeah. So there's a number of things we need to do, but I think these are all going to fix problems that we already have. So it's going to make the world a better place. And in the end, we're going to have a machine local cache, which is going to help a lot with anything local. So anywhere where you are going back to a state where you've been before, not repeating that work, switching branches, bisecting, Android development, and we're going to have a shared cache feature as well, and we're going to provide analytics with Gradle Cloud Services, and this is going to be awesome. And yeah, please go ahead and start preparing for the future. So yeah, thank you. And if you have any questions, I think we have like 15 minutes. So yeah. Yeah. Please. So the question is, what's our cache eviction policy? So this depends on what kind of architecture we are looking at. So for the machine local cache, which we are going to ship with Gradle itself, we are going to have a cache eviction policy, and it's going to be probably something size-based that you can configure as a user. For anything shared, this is the unsure part. So we might also ship something as a separate product, or maybe as part of Gradle Enterprise. But you can also set up your own environments, and then it's basically the user's responsibility to come up with an eviction policy. Okay.
You were talking about if two tasks are running the same, is it disable caching for both?
So the question is if we disable caching for both tasks when they are writing to the same directory, or just one of them. I think we should be disabling for both, or maybe just not do any caching if there's any of this business going on. This is something we need to figure out. Like, look at real world examples and see what would be the best way to go about this. What we know is that this would lead to problems if we didn't do something about it, and we should really warn users that they have this problem and give them an opportunity to fix it. I don't think it's going to be very hard to fix in any circumstances. You can always split things up and do the same operation in 2 steps maybe to fix a situation like this, but it needs to be fixed in some way. Or you can just decide that, hey, I'm not going to use caching for this task because I don't need it there. Okay. Yes? So is it based on the file contents? Yeah. Yeah, so we only care about the contents. We don't care about the date. There are some optimizations based on the file date, but in the end, we just care about the contents and the file name, the part of the file path actually that you tell us to care about. Okay. Yep. This is what we are unsure of at this point. So yeah, we need to figure out what we are going to do about that. But yeah, I don't know. That's at this point. It's most probably going to be so what we are going to provide is analytics and extra insight as part of cloud services. So it's we are probably going to support a number of options for you to use, but not any kind of cache, because we need to have some integration with cloud services. Does that answer your question, roughly? Okay. Sorry, I can't say more at this point. Yes? Oh, sorry. The question was if I understood correctly, is that if can you use your own shared cache, or are we going to ship something? And I think the most precise answer at this point is that we are going to support a number of options, but not anything. So Nexus Artifactory, yeah, or Hazelcast, or yeah, there are lots of options we can consider. Nexus Artifactory, they are probably a little bit too heavyweight for this job, but no, we haven't evaluated them as options. They are definitely on the table, but not. We don't know the answer at this point. If there's a high demand for them, then probably we are going to. If they're technically feasible, we are going to support them, but I can't really commit to that at this point. Yep. So the question is, how do we deal with the cache becoming too large and parts of it not being used? So, well, we are going to have some kind of eviction strategy for every for a cache in any way. And of course, this is where cloud services comes in, where you get a lot of insight into how the cache is used, who's pushing entries into the cache that are never used, for example, who's pushing entries which are used a lot, and you can make decisions on your own based on that to optimize cache usage, maybe switching it off for certain projects, or yeah, there's lots of options. We can recommend you to do certain steps, like the current build scans feature recommends you to do certain things to optimize build times. We can do the same with caching. Okay. Any other questions? Yep.
So for the distributed cache, how big of a challenge is it to determine whether it's going to take less time to redo the calculation or just to retrieve?
Yeah, so I think what we can do is to do the other way around. So when we are about to store the results of a task in the cache, we can check if it took a long time or if it was really trivial to execute, and make a decision based on that. So this way we don't just save on we also save cache space, because we're not, and upload time. Yeah, so it's most probably some ratio between execution time and the size of the artifact that we would be uploading, because of course upload time is can become a significant overhead as well. Any other questions? Yep. Yeah. Okay, so what do we do with corrupted entries in the cache? Yeah. So yeah, that's an issue. So because of course there's no actual way for us to check if the task says that, hey, these are my inputs and these are my outputs, and we can't really make absolutely sure that you are not incorrectly stating those informations. So this might happen that we end up with an incorrect entry in the cache, and we are going to have some tooling around this. So to both to track down these problems, to see where an incorrect entry has originated from, who built it, with what parameters, and also ways to evict these incorrect entries from the cache. Any other questions? Okay. Okay. Well, thanks for your attention. And